Okay, so I have given some example you as a homework. Okay, tell me whether you've done with all the examples. What is what the example I have given as a homework to find the truth table. Have you done with that? Yes or no? Yes or no? Am I audible?
Yes.
Okay, what about these examples? Have you done this? I'm not getting your voice. Whether my screen is visible now?
Yes, sir.
Okay. So write down the next example. Before going to start with the example, let's write down the remark or write down the definition of tautology and false statement. So write down. Yes. First it's remark, tautology and so when the statement is tautology, yes, if the output of Boolean expression is the output of Boolean expression is always what? Is always what?
Positive.
Positive or true?
True.
True or sometimes it is 1. Then that Boolean expression is tautology. Okay. And second, if the output write down with me everyone. Boolean expression is what? False or in terms of number it is 0, then that statement is called as what? Then that Boolean expression is false. Got it? Got it? So we already have example. We already see one of the example here. See that statement x plus x bar. X plus x bar is tautology. See whatever the output I am getting, that is always true. Okay, and the above example x dot x bar, whatever the output I am getting, it is always false. That's why it is false statement. So these are the two examples. You can write down these examples. Now the next question. Check for tautology on C. Number one. So let's take one example. So what we have here, we have P plus Q its complement. So check it out whether it is tautology or what. And tell me. Everyone just find out how many variables we have here. How many variables we have?
Two variables.
So how many combinations we have? So I just write down here first Q, here Q.
4 combinations.
4. So first I write down 0, 0, 1, 1. And then I write down here Q. Q is number 0, 1, 0, 1. So we need to calculate first P dot Q. So what is P dot Q here? P dot Q. Just tell me. What is P dot Q?
0, 0, 0, 1.
0, 0, 0, 1. Okay, it is AND gate. Yes or no? So for AND, what we have, if both are 0, then 0. Either of one is 0, 0, 0. If both are 1, if both are 2, then we will get. Then we have it's called as negation. So what you are getting? P dot Q, it's negation. So what is the negation? What you are getting here? 1, 1, 1, and 0. And then you need to add P plus PQ, its negation. So we have this term and we have P. You need to add plus here. First plus is nothing but which gate? OR gate is there. OR. So this or this, what you are getting? 1, here also 1, here also 1, and here also 1. So what is my output here? My output is always true. Whatever the combination I have. Okay, so I have for this combination, this combination, this combination, this combination. For all the combination, my output is always true. So what this implies, you can write down my output is always true. So for above expression, output is always true. This implies the Boolean expression is tautology. Got it, everyone? Yes or no?
Yes, sir.
Okay. So this is what we have for the tautology. And similarly, when we have particular statement, you just go for whether if the all outputs are false or 0, 0, 0, that time you can say that that particular statement or Boolean expression is false. Okay. Now what we have, we are going to see some of the properties. Some of the properties. So before going for the properties, that gates are also used. So what we have, logic gates. Okay. So how the logic gates look like, what are the symbols of logic gate that we are going to see, and then we will go for the some properties of that gates. Okay. So Boolean algebra, whatever we are dealing with the Boolean algebra, it is applied in computer as well as electronic circuits. Okay, so in that particular circuits, we perform a Boolean gates or logic circuits we call as logic gates. Okay, so what are that logic gates? So let's see for the logic gates. Write down everyone. Logic gates. Logic gates. Okay. So yes. No, after please mute yourself if you're joined right now. Please mute yourself. Okay. So write down a gate is an digital circuit. Sahil Jain. Sahil Jain. Okay. So gate is an digital circuit. Digital circuit which operates on one or more signals what happened? What is and produce single output. Okay, so it is a digital circuit. It is nothing but a digital circuit which operates one or more signals and produce a single output. So whatever we have AND gate or gate, just write down all the remarks, then we will do for that one. So it has input and output. So what are the inputs? So gates are digitally, write down. Digital circuit because the input and output and input and output signals are denoted by either one. What is that one stands for? One is nothing but high voltage or zero, that is nothing but low voltage. Okay. So these are nothing but the digital circuits. Here, the one is denoted by the high voltage and zero is denoted by the low voltage. So we have three types of gates. The first type is nothing but AND gate. Second is nothing but OR gate. And third is nothing but NOT gate. Now we are going to see what are the symbols and what are the outputs. Okay. So for Boolean expression, whatever we have the Boolean expressions here, where we have, yeah, this is logical operators. Here also we have AND, OR, and NOT. Okay. Here we just consider 0, 1, 0, 1. Here AND is nothing but your conjunction, disjunction, negation. We denoted by plus, dot, plus, and bar, and comma, or comma. So like that we have for the gate 1, 3, important gates. That is nothing but the same gates, and, or, and not. Okay. So what is the symbol of AND gate? So write down first.
So can you scroll a bit?
Okay. So we will first start with the AND gate. If you're done with that training,
Yes, sir, done.
okay. So in the AND gate, the AND gate is the electronic circuit that gives high output. High output is nothing but one only if all its inputs are high. Okay. So AND gate, we write down that AND gate is an electronic circuit we need to do the group activity on that also. We need to do the group activity on that also. Okay. So AND gate, where we are, AND gate is an electronic circuit, yeah, that gives high voltage. That gives high voltage. High voltage is nothing but you call as here one. High voltage is nothing but one. Only if it's all inputs are high. Suppose we have, and what is the symbol? Symbol is like that. We have A here, we have B here. If I give A and B are the inputs, and if I use here and gate, AND gate, so AND gate is denoted by that. So this is nothing but your AND gate. And gate, what is the definition of gate? The definition of gate, we have one or more than one inputs, we have only single outputs. So I have one output. That output here we denote it by AD or A dot B. Whatever we have got, we operate here. And what is truth table of that? Suppose I have A input, and here I have again input B. So what are the possible values A and B have? Either A has 0, that time B also has 0. Both have low voltage. Either A has low voltage, B has high voltage. Either A has high voltage, B has low voltage. A has high, B has high. So these are all the possible 4 combinations that we have already done. We know that how to write that. What is output here? Output is nothing but AB. And what they are saying, AND gate is an electronic circuit that gives high voltage one only if its all inputs are high. So this time only that time that will give high voltage. Otherwise, this will give you a low voltage. So this is what we have the table for AND gate. Whatever we have operations, the same operation we use here. You can understand this? Yes or no?
So please explain
Yes,
that
sir.
again.
What?
So that table, can you please explain again?
Very simple. What is the table of AND table we have for 0 and 1? This is only the same table. This is only the same table we have. Just here what? They just explain it in another way. What is that another way? What they are saying? The AND is a gate, which is an electronic circuit. So suppose we have some electronic circuit like that, and that AND gate is denoted by like this. So whenever this kind of gate we have, this is the AND gate. It means my input is 1, A and B. These are my inputs. So either my inputs A has high voltage or low voltage, we don't know. Similarly for the B, whether it has high voltage or low voltage, we don't know. But my output is AP. So we need to check what is my output. But if you have AND gate here, it means what? What are the possible combinations we have for that two inputs? So that inputs have these many possible combinations, only 4. 2 raised to n. Okay, because we have two variables. So here either it has low voltage, we also have low voltage. A has low voltage, B has high voltage. A has high voltage, B has low voltage, and both has high voltage. These are the possible combinations. And accordingly, what is my output? So my output is what? That gives high voltage only if when all outputs are high. It means when all outputs are high, that time I will get high voltage. Otherwise, I will get low voltage like that. Got it?
Yes, sir.
Now this is the same gate. Whatever we have operator, Boolean operator, and this truth table is same. You can check it out. But this is work. This is work in electronic circuit, and this is we will work in computer applications. That's it only. So this is for your revision purpose only. Now we have OR gate. Second. So what we have in the OR gate? OR gate is an electronic circuit that gives. This is electronic circuit. Electronic circuit that gives high output. Tell me when this will give a high output. High output if, yes, tell me if
Always will give high output only when both the cases are low, then only low output will be given.
okay, that is also correct. That is also correct. You can write down this way like that. This is the electronic circuit that will give you a low output when both are low. Or if I wanted to write down in that way, high output 1 if one or more one or more of its inputs are high. Of its inputs are high. Is it okay? Okay. If both are high, then only we also get high. If one of them is high, still I will get high output. If both are low input, okay, that time we will get low. So write down this. It is denoted by. I just try to draw. Anyone knows what is it?
Fine.
Yeah.
Arrow type ending like arrow.
Something like that. Something like that. Yes or no?
Yes, sir.
And here we denoted by it is A plus B. That plus is nothing but what we have or that we already have. Input 2 or more. You can give 2 more, 3, 4 input. That it doesn't matter. But this is what they have denoted. And now input and output. Input of A. Input of B. And here output. Output is denoted by A plus B. All possible combinations 0, 0, 1, 1, 0, 1, 0, 1. Okay, I just write down the progress. For this we have 0 here. For this we have 1 here. For this we have 0 here. For this we have 1 here. So what happened here? The electronic circuit gives high output if one or more its output is high. So this is low, low. So this will go. Either of one is high. So high output. Either of one is high. High. Both are high. High. Like that. Write down this. This is for what we have OR gate. What about NOT gate? Everyone done with that? Tell me.
Yes, sir.
Now third one, not. Tell me what I should write down in the NOR gate. Okay, this is electronic circuit with, yes, next.
That gives high output if its input is low.
Okay, any example? If it is electronic circuit, do you have any example? This is an electronic circuit that gives
High output if its input is low.
high output. That is one if its input is low. If its input is low. Do you have any example for any electronic circuit? Any example do you have? What about inverter? You have inverter here. Whether it is the example.
Yes, sir.
How can you explain?
Sir, when the light goes off,
It means we have zero low. This is what the
low
not.
input.
That time we have low input, correct?
So it switches to the inverter. Its internal circuit
Okay.
for
And that will give you a high output.
high
Exactly.
output.
Exactly. So inverter is the one example, real life example. Okay. So what happened when output is nothing but what? Suppose I have here my tube light. So this is my current. This goes my current to the tube light. Okay. If NOT gate is there, if the light is on, I have my electricity. Okay. If I have my electricity, that time what this will give you output is high, but they are not giving any output. My input is high. My input is suppose 1. Okay. So 1 goes here, but there nothing goes change because it stops here. It's, in a charging mode. Is not output is 0 that time. But when my electricity goes, that time he will turn off his charging mode and he gives the output as a high. Okay. So this is what you understand for the. So that gate, that's why that gate is also called as that inverter word comes here only. So that NOT gate is also called as inverter. So you can write it is also called as inverter. And the table it's very simple. If my input is A, my output you can call as A bar. When we have 0, it goes to 1. When we have 1, it goes to 0. Okay. So this is what we have for the NOT gate. Everyone understand that? Is it okay?
Yes, sir.
Okay. Now we have our next point, that is nothing but a principle of duality. So what is duality principle? Anyone knows what is duality principle? Have you heard that word? Duality principle? Principle of duality. Anyone knows about this duality principle? Yes. No one. Okay. Write down. Write down something in the duality principle. In Boolean algebra, the duality principle can be obtained by interchanging and or gate operators or gate, and replacing zeros and ones and ones and zero So what happened in Boolean algebra? What happened? The duality principle can be obtained by interchanging and or gates. Okay. Suppose you have AND gate, instead of AND you need to use OR gate, and instead of OR you need to use AND gate, and also replacing zeros and ones. When we have zero, you write down ones there. When we have ones, you write down zero here. That is nothing but you can interchange its and or and zeros and ones. Okay. Compare the identities then. Compare the identities on the left side with identities on the right. So, for example, so let's see the example. Suppose I have my Boolean expression x dot y plus z dot. Can someone tell me what is the duality of this? Yes? Anyone? What is the duality of this? What is the dual of this statement? So dual in terms of what? The meaning remains same. Whatever you wanted to say, that this will remain same as it is, but you can express that expression in another way. Okay. So anyone? You can tell me. We will just discuss this. Whether it is correct or not, we will discuss later on.
X plus y dot z
X plus y
dot
you mean to say y dot or bracket dot?
no sir, normal like multiplication wala dot.
Okay.
I might be wrong, I'm not sure.
No, yeah, it's okay. So dot z you are talking about. Okay. Any other one? I just made a bracket here if you wish to, because this is also important, no bracket. Here, obviously, we have first bracket here, and then we have this bracket. Yes. Any other one? The remains. Okay, let's first find out the truth table. So what happened? Whatever the truth table, whatever the output of that statement, and output of its duality is always same. Is always same. So let's check it out. X, Y, Z. It means how many times we have here X, here Y, here Z. How many combinations we have when we have three variables?
8.
8. So is it 1, 2, 3, 4, 5, 6, 7, 8? Then 0, 0, 1, 1, again 0, 0, 1, 1. And here alternate 0, 1, 0, 1, 0, 1, 0. And here I have 1. Okay. Now x into y. So what happened x dot y? Tell me. So we have this table and this table. Okay. For dot, if both are 0, output
Zero.
is 0. Here also 0. What about here?
0,
0. What about here?
0,
0. Here
0,
also
0,
0. Here I will
One.
get 1. Here I will get 1. Now what we have? Z complement. So z dot. Z dot is nothing but negation. So negation of this. Tell me. It is 1. It is 1. What about here?
0.
0. Next is 1,
1.
0,
1 0
1, 0, 1, 0. Now you need to add that. So what you should have? X dot y plus z. It means you need to do and get here, or get. What about or get? If either of one is 1, then you can write down 1. Yes or no? So we have 1 here, here 0. What is next?
1,
1,
1,
0 1
0.
0, 1.
0 1 1.
So this is my output. Okay. And if I try to find for output for x plus y and dot z, I can directly find what is x plus y. So here we have x, so I can find out here x plus y. So what is x plus y? X plus y 0 0. So tell me here 0. What happened here? Here also 0. Here
1
1,
1,
1
1,
1,
all 1.
1. Here also 1. Here also 1. Here also 1. And you are saying dot z. So x plus y dot z. So dot z, if I z we have here 1, 2, 3 lines, and
So I think negotiation will also be there.
yes, exactly. That is what. Yes. So this is not true. Everyone agree this is not true? Or whether I write down the table, because it said here only, see 0 0. If I product, I will get 0 here and I will get 1 here. Itself it is not true. Okay. So this is my output for the right hand side statement. So duality, this is not true. So this is not true. Okay, wrong. Yes. Yes. Any other one? So I erase that thing now. Okay. I erase that thing. Tell me now, any other one? So what you need to do, see, very simple. When we have zeros and ones, so negation also plays here important role. Turning 1 to be 0 and 0 to be 1, what it means? Replacing zeros to 1 and ones to 0, what it means?
Negation.
Negation is there. So you need to apply the negation also. What we have here, single x. So what is negation of that x? Is x dash. Here we have dot. What should I replace instead of dot? In
Plus.
duality, it is
Plus.
plus. It is plus. What about here y? Y also have single, so it's negation. Change its ones to 0 and 0 to ones. So when I take its complement, then and then only it's 0 and ones interchanged. So this is my done. Okay. Then we have plus. We can write down dot, and then we have z. We can write z only because negation get cancelled. So I think this is my correct answer.
So can we write it like x plus y whole negation?
Yeah, because right now we are not going through that rule only. Okay, and we don't know whether it is true or not. It is true. It is true. Obviously, what he wants to say, x plus y its whole negation is equal to x negation plus y negation. Like that we are talking about. No,
Yes, sir.
that is also the correct one. But we need to check it out whether it is correct or not. We need to verify which is what kind of law is this. Okay, but whether it is correct always. I don't think so because its sign changed. When we have here plus, it comes here dot. Yes or no? It is De Morgan's law. De Morgan's law. Okay, we will see that later on. This identity. This is nothing but called as De Morgan's law. A plus B complement is equal to A complement dot B complement. So when we have plus, it comes a dot. When we have dot, it comes a plus. You can check it out. For a simple example, if you wanted to check it out, here we have x, here we have y. So 0, 0, 1, 1. Here what we have 0, 1, 0, 1. If you calculate x plus y, what is x plus y? Tell me, what is x plus y? 0,
0,
1, 1,
1,
1. And its negation, x plus
Zero.
y, its negation. So
1,
here
0, 0.
1, all 0. Okay. And you calculate x negation. So x negation,
1, 1, 0, 0.
1, 1, 0, 0. What is y negation?
1
1,
0
0.
1, 0,
1 0.
1, 0. Am I correct? And now if you take a dot, so what is dot? 1, 1, 1. Here 0, this
0.
0, here. If
Zero,
you take
zero.
a plus, these two equations are not same. So that's why here dot is there. Got it? So this is the law. In the next lecture, we are going to discuss all the law. What is this all laws? Okay. But you can check, verify that. So don't write down this. The meaning of this is this. Okay, not directly plus plus. Got it, everyone? So, yes or no?
Yes, sir.
I think you are clear with this thing. This is called as De Morgan's law. So we have lots of law. De Morgan's law, associative law, idempotent law. So this law we are going to see in the next lecture. Okay. Now your target is what? For that duality statement, you need to find the table for this now. This is my table for right hand side. Okay. So for that statement, you need to draw a table from left hand side. Draw a table for this and tell me whether these two tables are equal or not. If it is equal, then the duality statement, duality expression of that particular statement is this. Check it out whether it is true or not. Find out. I just try to find out here only. So what we have here, x. So x we have, so 1, 1, 1, 1, 0, 0, 0, 0. Okay. Again we have y. So y complement. So 1, 1, 0, 0, 1, 1, 0, 0. Okay. Next we have plus in that. So plus is nothing but or. Or is nothing but here I will get 1, 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 here 0, here 0. Yes or no? Please check it out. Huh?
Yes, sir.
Now the final this table. This table is what we need to 1, 2, 3, 4 with Z. Z. To consider this and this. We have do the product. So what happened? We will get here 1. Am I correct? Next.
1.
No, how it is 1? Here we have 1. Here we also have a 1.
So
Okay.
1
Dot we are going to take with Z only. Yeah, we'll get 1. But why statement I am getting wrong? Here I should get 0. Here x dot y. X dot y is here. X y 0 0 and Z complement 0. Then we have a plus, so it becomes 0. What happened? Whether I made something mistake here?
So
To
first
calculate
one should be 0, no?
how it is 0.
Because we are dealing with Z, no? So
Z what we have? Z have 0. So okay. Here I will get 0.
it's multiplication.
Yeah, multiplication means when both are either of one is low voltage or either of one is zero, and you can write down zero. First, we draw all things. Let's see. Then what happens? 0, 1. What is next?
1,
Zero.
Here
1.
and here. 0, no. Here, here.
Zero.
So
Yes.
This.
we are multiplying 1 into 1.
No, here 0 we have.
No,
No.
this is Z dash. We want Z.
We want Z. No. We want Z here.
Yeah, so Z mein second is 1 now.
No, third. We are talking about third. Second one is 1, correct. Second one is 1.
I was talking about the second one, sorry.
Okay. Third one is 0. Fourth one is 1. Fifth one is 0. Sixth one is
One.
1, no? Seventh one is 0.
Zero.
Eighth one to 0. So check it out whether these two are equal or not. I'm getting exactly opposite, no?
Yes.
Yes, sir.
What is the meaning then?
Negation of like
So I think we have to take
negation of whole like
If we take the negation, exactly. Yes, not negation. Duality means what? I just write down here. What I have, I just write down here what I will get. Is the table for x dash. Am I correct? X dash plus y dash into z. Duality is nothing but what? But duality, the output should be same. That is what I feel. Notice that is what I feel. Why I'm getting, if I take the negation, I will get this statement. Yes or no? If I take the negation of that side, so negation of x is nothing but x dot y plus z complement, like that. Okay, we will think on that. We will think. My question is just you also think in that way. What happened when this is the duality statement? That is correct one.
So
Okay.
can you
Yes.
scroll a little bit for the definition?
Definition, what definition? In the Boolean algebra, the duality principle can be obtained by interchanging and or gates or operators and replacing zeros and ones and ones and zeros.
So
Okay.
the second statement should be right now with that logic.
This one, no?
Yeah.
What you are saying, it replaces ones to zero and zeros to one. But what happened? Duality statement means nothing but what, you know? Yeah, my question. I have doubt now. What happened with the truth table? Whether truth table remains same or it will remains interchange. So we don't have right now nothing with me. So I will think on that. I will search on that, and in next lecture we will discuss on the same thing. What happened with the truth table? Okay. So what you are saying right now, that is also I agree with you. The zeros each replaced with ones and ones is replaced with zero. So whatever I am getting here, one, ultimately that one interchange to zero, see here, and zero interchange to one, and every time this happens. So duality statement, in that duality statement, whatever I am getting, the output would be not same, but it is interchange zeros and ones. So here I have my one output, here I have my another output. So this statement is dual of this when ones and zeros are interchanged. So you can see ones, zeros, ones, interchange. That is what I feel. But I will give you a brief information about this in the next lecture. Is it okay? Is it okay? Where we stuck? Whether these two tables are equal or not of the duality statement. Got it?
Yes, sir.
Okay. So we stuck here. My question or our question is right down here. Whether in duality truth table output are equal or not. We will discuss this question in tomorrow's lecture by taking simple examples or by understanding duality principle one more thing. Okay?
Okay.
But okay, please keep that question with us. Okay. So we have 3 minutes remaining. I will quickly take a attendance. Give me a minute.